Hello, and welcome to the laboratory component to EChem in a Box. In this section, we will be discussing the compact voltammetry cell, WaveNow potentiostat, and screen-printed electrodes that you'll be using for the 4 labs that come with EChem in a Box. The 4 labs include electrochemical analysis of acetaminophen in common pain relief medication, exploring Faraday's law using inexpensive screen-printed electrodes, highly sensitive electrochemical determination of lead in tap water, and electrochemical enzymatic determination of glucose in beverages. It should be noted that EChem in a Box does not provide you with the chemicals needed to do these experiments. We only provide you with the equipment necessary to perform the experiment. However, we've provided a list of all the chemicals that you will need, in addition to the purity needed for certain experiments. Chemistry experiments employing the use of chemicals and laboratory equipment can be dangerous, and misuse of chemicals and equipment may cause serious bodily injury. To learn more about proper laboratory safety practices, Pine Research Instrumentation encourages you to consult the book called Safety in Academic Chemical Laboratories, published by the American Chemical Society. Before performing any electrochemical experiments, you should wear the appropriate PPE, personal protective equipment, depending on the chemicals you are working with. The most common PPE used in electrochemistry consists of, but is not limited to, a lab coat, safety goggles, and gloves. Thank you, and be safe. First, we have our 20 milliliter scintillation vial. This is where the solution of interest is going to go for most of our experiments. Second, we have the compact voltammetry cell cap. This cap is made out of PEEK. There is an O-ring on the inside, and we need to put an O-ring on the outside. When screwed on, this forms a very nice tight seal with the scintillation vial. Next, we have our large volume cell. This has a nice flared bottom, which is good. It's hard to knock it over, especially when students are handling it. This fits inside like so. And then it comes with this nice red cap, which we can screw on top. This forms the base of our compact voltammetry cell and all the glassware. Next, let's look at the screen-printed electrodes. For most of the experiments, we will be using the carbon screen-printed electrode. Where we have the working electrode is the 2mm diameter electrode in the center. The counter electrode is this U shape on the side. Then there's this little tiny silver chloride dot that acts as your reference electrode. To connect the screen-printed electrode to the potentiostat, we use a grip mount containing a small circuit board that maps the electrode to a mini USB. The grip is compatible with both ceramic and polymer-based screen-printed electrodes. To adjust for the difference in thickness between the two electrodes, we've included a spacer which fits behind the polymer screen-printed electrode, so one grip is compatible for all screen-printed electrodes. And that fits quite well. Then we are able to put it right into our compact voltammetry cell. Now when using this, you want to make sure that you fill the solution up so that all the electrodes are submerged in solution. As I mentioned earlier, the grip mount is compatible with both ceramic and polymer screen-printed electrodes. For the electrochemical enzymatic determination of glucose in beverages lab, you will need to use our platinum screen-printed electrode, which is on a ceramic support. The ceramic electrode is thicker than the polymer electrode and does not require a spacer to use the grip mount. When using the screen-printed electrode with this grip, the grip has 2 mini USB style connections. When the electrode is facing you, you always want to connect the mini USB to the left. This allows you to make the electrode interchangeable, so I can also fit it in the other way, but I have to use the right hand grip. Another component that comes with EChem in a box is an optional silver-silver chloride low profile reference electrode. This will be useful for certain labs where you can't use the onboard reference electrode, and you need a separate reference electrode connection. Let's talk about the potentiostat. The potentiostat you will be using in EChem in a box is our WaveNow potentiostat. On the right hand side we have a 15-pin connector which connects to our cell cables. And we also have an analog output signal. This is used mainly for rotating disk and rotating ring disk electrochemistry and shouldn't be necessary for the labs in EChem in a box. On the other side we have our power switch, our power plug, and our serial USB connector. So let's connect the power. Power cord fits in like this. This is our serial USB connector. Plug that in. Note that on the other side, the serial USB should be a USB style connector, which should go into your PC, laptop, or desktop. On the other side, there are two options for cell cables. The WaveNow potentiostat comes with our standard cell cable, 15-pin connector, and if you're doing traditional electrochemistry, you have traditional electrodes rather than screen printed electrodes, you would use this type of cell cable. Our red plug is for our working drive electrode. Orange is the working sense electrode. Most of the time the working sense is actually shorted to the working drive electrode for the majority of experiments. The green connector is for our counter electrode, and the white connector is for our reference electrode. The black connector is if you want to ground the potentiostat to a grounding point, such as earth ground. The primary cell cable that you will need for EChem in the box is this one. This one, again, has a 15-pin connector. However, the output is to a mini USB connector. So if I connect this in, with this mini USB style connector, I can connect this to the grip for the compact voltammetry cell. As you can see, I have my carbon screen printed electrode with a spacer on the back. Let me put this in. And then I'm able to put it right into my compact voltammetry cell. And there you have it. That's all you need. Next thing you need to do is turn it on, and you're good to go. In the next section, we will be going over Aftermath software and perform the experiment electrochemical analysis of acetaminophen in a common pain relief medication. To perform this lab, I will be using some children's Tylenol and some saline solution. I'll see you soon.